carbon and its compounds. So when two or more elements they combine, they form compound. And there are two types of compound. One is organic compound, the other is inorganic compound. And what are these organic compounds? They consist of carbon and hydrogen. These are organic compounds. So there are certain bonds like ionic bond and covalent bond. The ionic bond is formed by the permanent transfer of the electron. But the covalent bond, as we are discussing the carbon, so covalent bond are those bonds which are formed by sharing of pair of electron between two atoms. These are covalent bonds. So carbon has 4 valence electrons. So carbon forms covalent bond, and the carbon exists in two forms. It can be in free state or a combined state. The free state form of carbon is graphite, diamond, fullerene, and in combined state you will see carbon dioxide, glucose, and sugar, etc. What are allotropes of carbon? See, any element which are of the same chemical combination or chemical property, but they are different in their physical property, these are known as allotropes. So in terms of carbon, we have 3 allotropes: diamond, graphite, and fullerene. So diamond, this exists as a three-dimensional network with very strong carbon-carbon covalent bond, and the diamond is quite hard in nature and high melting point it has. You know, it is used as a jewelry material, so it has a lot of luster and it shines very well, and but it is bad conductor of electricity. The most common use of diamond is jewelry, and because it is hard in nature, so it is used in cutting and drilling of tools. Then we have graphite. Now this graphite is made up of van der Waals forces, which are weak forces, and each carbon atom is bonded with other 3 carbon atoms. So other 3 carbon atoms like this, in order to form hexagonal rings. It's a good conductor of heat and electricity, and generally it is used in machine parts as dry lubricant, and also used in lead pencils. Fullerene, it's a hollow cage. See, it's a structure, you can see that it's a hollow cage structure, and it is of the form of sphere, and the structure is similar to fullerene, but see, here we have a pentagon and here we have hexagon. 6 edges are there. So it along with these hexagonal rings, you will see pentagonal and heptagonal rings also there. Two important properties of carbon: one is catenation, the other is tetravalency. Tetra means 4, so tetravalency. Catenation is property of carbon by which the carbon atoms can link one another using the covalent bond, and it can form long chains, closed rings, branch chains. And carbon atoms, they can be linked by single, double, and even triple bonds. Carbon has valency of 4, because of which this is known as, or carbon is known as possessing tetravalency. And due to this, one carbon atom can combine with other 4 carbon atoms, with other atoms such as oxygen, nitrogen, etc. Hydrocarbons. The name suggests hydrogen and carbon. So compounds which are made up of carbon and hydrogen, these are known as hydrocarbons. So there are 2 types of hydrocarbons: saturated hydrocarbons and unsaturated hydrocarbons. So these saturated hydrocarbons, they have single bonds between carbon atoms, like the alkanes. These alkanes are in the category of saturated hydrocarbons. The formula is CnH2n+2. So if I place say 2 here, H2 into 2 plus 2, C2, H2 2 is 4, and then plus 2, C2H6, ethane. Likewise, these are all saturated hydrocarbons following this formula. So unsaturated hydrocarbons are those which have double or triple bonds between carbon atoms. For example, alkenes and alkynes. So these alkenes have formula CnH2n. Same way you are going to do it. And alkynes have general formula CnH2n minus 2. So these are the example of saturated hydrocarbons. And these are the examples of unsaturated hydrocarbons. See, the name is given like this: ethane, propene, and butene. After that, because this is 5, this is penta, so pentene. 6, hexa, hexene. 7, hepta, heptene. 8, octa, octene. The structure of hydrocarbons can be represented in the form of electron dot structure as well as the open structure. So this is an example of electron dot structure. These are electron dot structure, whereas these are the open structure. Both are signifying the same thing. In the electron dot structure, see, this is carbon. So it has 4 valence electrons, 1, 2, 3, and 4. Now these are combined with hydrogen, 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 one with this carbon. So this carbon and this carbon is sharing electrons, others are also sharing electrons. So this kind of representation is electron dot structure. But if you show the bond by a line, these are known as open structure. So this is an open structure of ethane. This is electron dot structure and open structure of ethyne. Carbon compounds, they are based on basis of structure. They can also be straight chain carbon compound. As you see, there is a straight chain. Then here we have branch chain compounds. So this is there, but it has a branch also. There is a branching. This has 1 branch, 2 branch, 3 branch, and 4 branch. So it's kind of a branch chain compounds. And in this case, it is making a cycle. So if we start from here, we will come to the same point again. So it's a kind of cyclic compound: cyclohexane, benzene, pyridine. These 2 lines means double bond. This means nitrogen is there. Functional groups. One of the hydrogen items in hydrocarbon has carbon and hydrogen. So one of the hydrogen items or atoms in hydrocarbon, this can be replaced by some other atoms depending upon the valencies. Now the atom which decides the properties of this carbon atom, these are known as functional groups, like the chlorine, bromine, hydroxyl, aldehyde, ketone, carboxylic acids. These are functional groups. We have homologous series, the series of compound with same functional groups or functional group substitute for the hydrogen atom. As I just said, this hydrogen atom in this hydrocarbon can be replaced by these. So the series of compounds in which the same functional group substitute for the hydrogen atom in a chain of carbon. Here we have homologous series, alkenes, alcohols, and carboxylic acids. See, these are of the formula CnH2n plus 2. These are CnH2n. The functional group is this one, C double bonded with C. The functional group in this case, methanol, ethanol, propanol, butanol, is OH, hydroxyl. Then in this we have COOH. These are carboxylic acids. Methanoic acid, ethanoic acid, propanoic acid, butanoic acid. These are all carboxylic acids. How do we name the carbon compounds, the nomenclature of carbon compounds? First of all, we have to identify the number of carbon atoms in compound. Then we need to identify the longest chain. Then depending upon the functional group, we assign the suffix and prefix. See, this is the name, suffix comes here, prefix comes here. So cyclic hydrocarbon, they are often given the name as cyclo, prefix is cyclo, then the name comes. If there are 2 or more different substituents, then they are listed in the alphabetical order. If the same substituent occurs more than once, then the location of each point on which the substituent occurs is given. For example, see these are functional group, and what is the end here? An. So this is the suffix ending, and these are for CH atoms. If we have OH, we give OL. So this is alcohol. Ene, double bonded. Ene, alkene, alkyne, ine for C triple bonded. Aldehyde, Al, C double bonded with O and single bonded with H. Amine with N. Ether with O double bonded. Then ester, O8, like this, C double bonded and C single bonded. Ketone, one, C double bonded with O with others. Nitrile with Ile, C triple bonded with N. These are different functional groups. Chemical properties of carbon compounds. Combustion. This is one of the chemical properties of carbon compounds. So carbon, along with the carbon compound, is used as a fuel because it normally burns in the natural being and it releases energy, and this energy is quite heavy, means the fuel, as a fuel, the energy being released can be utilized. So the saturated hydrocarbon, they produce blue and non-sooty flame because they burn properly, while the unsaturated hydrocarbons, they produce yellow sooty flame. Oxidation. The alcohol can be oxidized to aldehydes, whereas these aldehydes can be oxidized to carboxylic acids. The oxidizing agent like the potassium permanganate, this can be used for oxidation. Addition reaction. The hydrogenation of vegetable oil is an example of this addition reaction. See how to convert oil into ghee. Oil into ghee. So addition of this when we add hydrogen in presence of catalysts like the nickel or palladium, this converts the oil into ghee. So this is how the addition reaction takes place. Then the substitution reaction. What is substitution reaction? When an atom or one atom of hydrocarbon is replaced by chlorine, bromine, because these have valencies of 1, they fulfill it by when one atom of hydrocarbon is replaced, so they replace one. Like this in the methane, CH4, this chlorine, when they combine, or this one bond of hydrogen is replaced by chlorine, so this is a substitution reaction. Chloromethane is formed. There are important carbon compounds like ethanol and ethanoic acid. So this ethanol is volatile liquid. If you keep it outside, it will just it will vanish because it is just volatile, and it has low melting point. It reacts with sodium to form sodium ethoxide. See, it reacts with ethanol reacts with sodium to form sodium ethoxide. So this reaction is used to test the presence of ethanol. How? Ethanol, because this reaction is evolving or liberating hydrogen. Then the dehydration of ethanol in presence of, say, sulfuric acid, it gives you alkene. What it gives you? Alkene. Ethanoic acid is colorless acid. We are talking about ethanoic acid. And when pure ethanoic acid freeze like ice, it will give you glacial. It is known as glacial acetic acid. Glacial has come from glaciers, and it is formed at temperature of about 16.6 degrees centigrade. This ethanoic acid or acetic acid, when they react with ethanol, ethanoic acid, when they react with ethanol, they form ester, and ester can be easily classified by their sweet smell. And when the reaction of ester is done with strong base, soap is formed. This is known as saponification. This acetic acid react with strong base to form sodium acetate and water. Soaps and detergent. So what are the soap and detergent? Soap is what we use to clean our body, and detergent we use to clean our clothes. sodium and potassium salt of carboxylic acids, they are known as soap. They are known as soap. So they work most effectively in soap water. And what are detergents? These are sulfonates or ammonium salt of long chain of carboxylic acids, and they can work effectively on soft as well as hard water. So this soap work on soft water, but these can work on soft as well as hard water. So what is the way, or what is the action of this soap and detergent, and how they actually clean things? So the cleansing effect of this soap and hydrogen is because of the ability to minimize the surface tension of water, because the body and the dresses have all the grease and dirts, etc. So how it does, it minimizes the surface tension of water in order to emulsify oil or grease, and it holds them in suspension of water. So when this soap dissolves in water, it will form anion and cation, soap anion and soap cation. There are two parts, hydrophobic and hydrophilic part. This hydrophobic part of soap and detergent, they are soluble in grease and dirt. Hydrophilic part is soluble in water. So there is a micelle formation, soap and micelle formation. So when dirt and grease, these are with soap water, the soap molecules, actually these are all soap molecules, they arrange them in tiny clusters. These are known as micelle. So the hydrophilic parts stick to the water and form outer surface of the micelle. You can say a small bubble, you can assume like that. And hydrophobic part binds to oil and grease. This is how it carries out the cleansing action.